Hi, I'm Jerry Weber. I'm here to do a JUnit testing tutorial for my software when testing class, but also useful for pretty much anyone who has any questions. So, what is JUnit? JUnit is a testing framework. It's open source, which is always good. Everyone in the computer world loves open source. And it's part of the JUnit testing family. It's there's CUnit, a few different units. They're not really very related, but they're all grouped under the JUnit family based on naming similarities. But other than that, it's a automated testing framework. Saves you a lot of time down the road. Why JUnit? There are different forms of testing, but this one is a particularly easy one, especially for Eclipse lovers and some of the popular IDEs as they're built in. It's easy, convenient, versatile. You can do all sorts of different testing with it. As I had mentioned, it runs in a lot of your favorite IDEs that we're encouraged to use both in school and just because they're easy. IntelliJ, NetBeans, Eclipse, and the list goes on. It can be used through command line. If you're not an IDE fan, there are a couple who are a bit old school or just enjoy the fun of using command line. And the automation of the test saves you time from having to run through manually, setting up every case, every condition, so on and so forth. For this presentation, I'm going to be using Windows 8. Not necessarily my favorite operating system, but it's on my laptop, which is what I was working with. I'm going to be using my favorite IDE for Java, which is Eclipse, and I'll be using Java 1.7. Now, getting started, if you have Eclipse installed, like I did, you're already done. It's part of the Eclipse package. It's already installed. You got it when you put it on your computer. If you're not using that, if you want to go through command line, or if you're using an IDE that does not have it involved, you just go ahead and follow. I got a couple basic steps here on how to get it on your computer. To get set up, you're going to want to get the newest version of JUnit. I have a link there for the SourceForge. Quick download, very quick. It should be downloaded in a zip file. Mine actually came out as a jar, even though the website said zip. If it is zipped, just unzip it to a directory of your choice, C drive, desktop, wherever you want to put it that you can remember where it is. If it's a jar file, that step's already done. Just put it where you want it. Now, if you want to test and make sure that the JUnit is actually functioning properly, you can open up your command line, go to the directory where you put the jar file, and there's a command to run. I have it in my slide. Nice and easy, one line. Where it says junit.jar, you want to make sure you have the full file name. It's not going to be just junit.jar. It's going to have the version number. Mine was 4.110 or 10, I believe. So replace that junit.jar within brackets with your version and run that test. And you should get the same results that I have here on the screen. All tests passed, no problems, short results. Now, for creating the first basic test case, and this is really what you're going to do for any test case, you're going to open up your Eclipse. As I said, that's my favorite. You're going to go ahead and create a new Java project. I called mine JUnit Testing just because I want to keep it separate from all my other projects, keep it easy. Straightforward naming is always best. You're going to want to right-click on the source folder, go File, New, Other, JUnit, and then you'll find JUnit Test Case. I've created mine Assert Test because that's going to be the first test I will address in my slides. All right. The first part of the JUnit framework we're going to be covering is assertion tests. I'm just going to go over a couple basic examples and then some more in-depth information, but we'll give you a couple basic examples you can try yourself. Nice and easy, a few minutes. Like I said, we're starting with the assertion test. It's a basic value checker. It doesn't have really any big complex uses. It simply checks the experimental value against the actual value, manually input. If the values are the same, they pass. Any other condition results in a failure. It's that simple. The example we used, I just did a real basic bit of math. I mean, the whole class was, I think, 4 or 5 lines long, just adding 2 numbers that are passed through from the test case. The very basic assertion class It simply has the number that passes through and the assertion of a check. I believe I passed 4 and 5 through with the assertion of 9, and passes through just fine. Now, the assertion has 3 values in it, separated by the 2 commas there. You can see in the sample code as well as on the bottom. The first value is the experimental, the second value is the actual, and the third value is the delta. The expected value, again, that's the manual input. That's what it needs to be, what you think it needs to be, or if you have something from a professor that says what it needs to be, which is usually my case. Then you have the actual, which is the one pulled in from the program after the math is actually done. And then you have the delta. The delta is more to provide wiggle room for floating point error, so that, yeah, while you have some floating point error, it might still be the acceptable value. That just compensates for that. As you can see, when we ran ours, I got green bar. Green bar is good. Green bar means all tests passed. Not really significant considering I ran one on a very small bit of code. So obviously you can see just by looking down below that it passed. But if you're running a multiple, like later on when I talk, if you're running a test suite, green means all passed. Red means you got to look for the fault. So I have the green bar, so good for that. 0 failures, 0 errors, and right below that it'll tell you the runtime on the right in the blue and the test name. So we had a success. And then I gave an example. I went back and broke it on purpose so we can get a red bar. As you see, I added a second test. First test passed, second test failed, and that resulted in a red bar. Also, if you look back, the failure trace window, it's down below the results window, and that'll trace the faults. Again, because we're doing such a small test, it really doesn't matter. You can say, I only made one test case, it failed in that test case. But if you're running a test suite, the failure trace window is nice because it saves you time from having to search for where that red bar was caused. As you can see, failure trace shows us that it failed on the assert statement in the assert test.java. In large test cases, like I said, this is much handier. In this case, it's just more of a redundancy check for just the one test case. The next one I want to talk about is the assert null. It's just like the original assert statement, very simple, straightforward, nothing complex, very easy to use, very easy to see. Checks for one thing. Instead of searching for a value that you've given it, which is a correct answer or the expected value in the middle of a computation, it searches for a null pointer. It's useful for finding uninitialized data structures and any kind of hang-ups that are going to make your program ultimately fail. Now, the example we used is I made a conditionally initialized array, and then I just simply didn't satisfy that condition. It's not something you'd ever actually do in a program. If you ended up doing this in real life in a job or for a professor, they'd probably give you the weirdest look you've ever seen. But in this instance, this kind of butchered code is what I needed to make a straightforward example. So I have an array that needs to be initialized with a certain value, and I just didn't give it that value. Then I went ahead and created the test case with the assert null to check for a null pointer when I'm giving it the wrong value. And the success is in the failure. We got the red bar, we got the failure right there. It gives you the execution time, which is a little bit longer than the other ones, but again, milliseconds, really not big of a deal. Red bar for failure, no errors, 1 pass, 1 failure. And if you look at the trace, just like we did earlier, the trace shows us that it failed on the null pointer exception from the null assert. Like I said, in this case, the failure was a success. Now, the next one I want to talk about is a timeout test. This I wish I had used earlier on, especially with some of my earlier Java programs, which I have a habit of making infinite loops and burning out laptops. This is used to detect the presence of infinite loops. Straightforward, not just infinite loops, but really any object or computation, anything that's going to make your program run infinitely or just to a point where it shouldn't be. If it just runs, it could run for 20 minutes when really it should have taken a few, and there's an error. It saves you time from locking up your machine or waiting, and very easily implemented in existing tests, because it's just a little addition of one line, not even a full line, just a small parenthesis. For this example, I went ahead and made an infinite loop. Again, not exactly the best bit of code, but it's a nice example. We made an infinite loop with a while statement. While 1 is equal to 1, 1 is equal to 1. It's not going to stop. It's not, like I said on the slides, it doesn't only occur, or the timeout isn't only useful for infinite loops, it's good for any infinite computation. Anything that's going to cause the program not to stop or to run for an inordinate amount of time. Now, to make the timeout counter, all I had to do is make the same kind of structure of a test case that we have been. It's passing a number through that causes the infinite loop. The only addition this time, and I even put an assert in there, which it doesn't actually get to, but just saying you can add it in with other structures. You just add the timeout counter right next to the @test. I'm not sure if I've covered this up till now, but the @test is above each one of the actual test execution cases in the inside the file, so the program knows where to actually look for a test case. Similarly, there is an @ignore command you can put there, so that if you're testing some code that's not complete and you wish to ignore certain tests rather than delete them or rewrite a whole new test case, you can just put @ignore above the ones that aren't yet able to be used, and then go back and change it to @test. Saves you time, allows you to reuse test suites and test cases across multiple programs that are similar. Like I said, the timeout counter is in milliseconds. I gave it 1,000 milliseconds, 1 second for an infinite loop, nice and quick. What you want to keep in mind is if you're using this checker, it's not a counter. It's not made to do a certain amount of time. It's just looking for infinite or crazy long executions. So giving your program a little bit of wiggle room isn't a bad thing. You can give it a nice big number. It's okay if your program runs for 30 or 40 seconds for a basic computation. You're looking for infinite or too long. So make sure you give your program enough time to execute. Otherwise, if you give it 10 milliseconds, it's going to fail because that's such a short amount of time, even though you don't actually have an infinite operation. Results, when we run them, obviously. Failure, the infinite loop is going to run for more than 1 second. And again, if we look at the failure trace, it shows that it failed at the timeout command rather than at any other thing like the assertion I had in there. Never even reached the assertion, hit 1,000 milliseconds, running on the infinite loop, and terminated the program. Like I said, comes in real handy when you're stuck doing infinite loops on certain types of projects. Next part of the JUnit I want to talk about is the runner. It's a function used by JUnit for tracking and working with the test results once you've run the test. Now in Eclipse, it's built in. I know there are some versions where it's separate. You can use it as a standalone and whatnot. But like I said, we're using Eclipse, and for that, it's built right in. So after you execute your test, you'll notice at the top, as I have in the slides, that there's a bar. Now the bar is nice, easy to use icons. Mouse over them if you want more details. But I'm going to run through them real quick here. They're helpful tools to help you move between your results, and they really are handy, especially, as I'll show you in a minute, when you have more than one test. What we were doing before has one test. You don't need to scroll through anything. You don't need to change settings. It's one test. Even with a couple, it does become handy. So the first thing you have are those arrows, and that'll let you go through your results, up and down, step through your failures. So you don't have to track, okay, pass, 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 scroll, scroll, scroll. You just hit the next arrow button, moves you right to your next failure. Next up, you have the filter option to take out all the past results. This is great if you've got a bunch of results with just a couple failures. You take out all those passes and all you're left with a nice short list. It's even easier than using the stepping buttons. Just a nice short list of your failures you can see all at once. Other than that, you have some run configuration buttons and the history over all the way to the right. Now, the run configuration buttons allow you to rerun the tests or rerun the tests with just the fault and fail tests first. So if you have a bunch of test cases, couple failures, you don't want to run them all in the same sequence if the failures were towards the end. You can rerun them with just the faults first, and there's also a button to stop the test run. So if you want to quickly run and you only have 3 faults, you quickly run with failures first, those will execute, and then you can just end it right there rather than having to wait for all of your suite or all your cases to finish. Like I said earlier, there is the history over to the right. If you're running a lot of tests, you get fails that you fix and then they fail again, and you want to compare previous results, you You can drop down that menu and pull up your previous results with the time you ran them, the date, and all that fun stuff. It's all stored nice and easy, all in that one bar across the top. Now, we're going to utilize the JUnit runner here we're going to take all the tests that we've done, we're going to combine them into one big old class, and we're going to run them. We have all the files that we need in the same folder already, so I'm just going to run it just by copying over the code nice and easy. I got a list there of all the executable tests that we're about to run all in one big clump. So we'll go ahead and run that. And when you see the results, you see that we have one error. That was a timeout error I talked about earlier. It didn't actually fail. It just had an error of reaching the maximum time limit. I think I changed it actually shorter to 500 milliseconds. And then it moved on to the next test case, which, as I said, we had in the list earlier. It'll just go down sequentially by the @test commands. So we have one error, one pass, and 2 fails. And if you remember back, that was the null pointer, the assert, the infinite loop, and I think we had one more assert statement or something. I just gave you a nice long list of faults. And then I used the filter option to remove the pass test. And that brought us down to 3 results in the window, still with the red bar because we did have a failure, and the runtimes of each individually one of those. If you go ahead and select each one of those failures in the list, either filtered or not filtered, and you look on down at the failure track trace display, it'll tell you the detailed results about that individual failure. Just as we did earlier when there was only one, now we can just click on each one and see the same results sequentially or whatever order you need. Just select what you're looking at and it'll give you your details. Using the runner controls like we talked about earlier, if you want, you can rerun this test, and again with faults first, it'll only run those 2 failures, and then it'll run the pass and the error in whatever sequential order they were in. And again, as I mentioned earlier, if you wanted to, even for this short amount, you could rerun tests first, have those 2 fails pop up, and then hit the stop button before the last 2 tests execute. Saves yourself a little time, in this case a very little time, but if you have thousands of test cases, it could save you minutes per run and hours per day. It does add up. It's very convenient and very easy to use. All right, now up till now we've been talking about test cases, but that's one term you hear, but the main term you hear is test suites. Test suites are really helpful, especially for large projects. They're basically a combination of all those cases. They allow for really thorough testing of large programs rather than incremental testing by small cases, and they save you a lot of time. But another thing is you can build one essentially by yourself. You don't have to have one big project that you make a suite for. If you have a particular programming style or if you do a lot of programming of a similar nature, as you build those test cases, you can then convert them all into a test suite. I have a little bit of code here on the screen that shows you kind of how you make a suite. It's a basic piece of code, just like an array or anything else. It starts with making your suite, giving it a name, and then you just add each one of those cases to the suite bit by bit like you would to filling in an array. Really simple. So all you would do is once you get enough cases, or if you decide even with 2 cases, you just want to make a suite, you can use a little bit of code and make yourself a test suite by the cases you already have from work you've already done. So rather than spending a lot of time making new stuff, you get to recycle work you've already done. So it saves you time, and saving time is really important when you have large amounts of testing or programming or compiling. There's a lot of waiting and time-consuming activities in software engineering. So anytime you can cut out a little bit of that wait time, it really does help. Like I said, most of the time for small programs, you can get away with just using test cases like I have shown. Not as simplistic, but still test cases, a handful, a couple dozen. But if you're getting too large, if you're going to do anything more than a few dozen or even just a dozen test cases, if you have the time, make yourself a test suite, especially if that program is going to get bigger or if you're going to have to test it a lot. A test suite will save you a lot of time, and odds are you'll eventually break down and do it. So you might as well just start off by getting those cases together and creating your suite. All right, now what I've covered so far has just been your basic introduction to JUnit. Covered some basic, real simple stuff, really the first couple parts of JUnit that you'll be using, the infinite loop checks and checking for specific values, real simple stuff. There's a lot of stuff in the API for JUnit, everything from build up to tear down to executing portions of the code before the rest of it. It really is a versatile and very useful part of testing. If you have the time to learn, I greatly suggest you do. There are plenty of tutorials online. I might even be making some more. This was actually kind of fun. But yeah, it's very useful. What we did here is very basic, but it'll get you on the ground running and at least give you some of the terminology so that if you want to teach yourself, you can go on there. Like I said, there are plenty of resources. I have a slide here listing a couple of mine, actually all of mine, that I found very useful, very clear-cut. If you have a working knowledge of Java, you really shouldn't have much of an issue learning JUnit, and I really do suggest you take the time. Thank you.